This is the 18th question of TMUA 2023 exam paper 2. This is quite an interesting question. It says the equation x raised to 4 plus bx square plus c is equal to 0 has 4 distinct real roots. If and only if which of the following conditions is satisfied. It has 4 distinct real roots. I see b square greater than 4c, b square less than 4c. From the options, I see that if b square and 4c are there, some discriminant situation is happening. So for this is a power 4 equation. I will make it a power 2. I will assume that x square is equal to y, or x raised to 4 is y square. Then this becomes y square plus by plus c is equal to 0. Now for this equation, the first equation, to have 4 real roots, this quadratic should have 2 real roots that are positive. 2 real roots that are positive. Okay. Why? Because x square is y. So x square cannot be negative number. If x square becomes a negative number, then they become the complex roots. So, or imaginary roots. So x square is y. So y has to be a real positive number. Okay. So that means this quadratic y square plus by plus c should not only have real roots, but the 2 roots have to be positive also. Okay. So first of all, if they have real roots, discriminant of this quadratic y square plus by plus c has to be greater than 0. So discriminant is b square minus 4c is greater than 0. Or I can say b square is greater than 4c. Okay. Now if the roots, so this is for 2 real roots, this situation. Now if both of the roots are positive, if both the roots are positive, that means sum of the roots and product of the roots are positive. Because if sum of the roots are positive and product of the roots are positive, only in that case we can say both the roots are positive. Okay. Because let's say both the roots are negative. If both the roots are negative, product becomes positive, but sum becomes negative. If one of the root is positive, the other root is negative, their product becomes negative. Sum can be positive or negative, but the product becomes negative if one is positive and one is negative. But if product of the roots are positive as well as sum of the roots are positive, then we can definitely say that both the roots are positive. So product sum of the roots is given by minus b by 1 here. Okay. Coefficient of y square is 1. So sum is minus b. So minus b has to be positive. Okay. And product of root is c by 1. So c also has to be positive. So if minus b is positive, that means b is negative. Now b square is greater than 4c. That means b is greater than 2c, or not 2c. If b square is greater than 4c, that means b is greater than 2 root c. Okay. Or b is less than minus 2 root c. Okay. Now c is positive, but b has to be negative because b is less than 0. Now in this case, 2 root c. If c is positive, 2 root c is positive, and b square, b. If c is positive, root c is positive. That means 2 root c is positive. If b is greater than a positive number, b becomes positive. But I want b to be negative. So this is ruled out. If this is ruled out, then I am only left with this situation. Because c is positive and minus 2 root c is negative. And b has to be less than that negative number. If b is less than a negative number, b will automatically be negative. Okay. So the conditions that I get finally is b is less than minus 2 root c and c is greater than 0. So which is answer option D. C is greater than 0 and b is less than minus 2 root c. Okay. It's quite a logical question.